multiplying AI, we could spin off agents as fast as you want to spin off agents. And so, you now have 4 scaling laws. And as we use the agentic systems, they're going to create a lot more data. They're going to create a lot of experiences. Some of it we're going to say, wow, this is really good. We ought to memorize this. That data set then comes all the way back to pre-training. We memorize and generalize it. We then refine it and fine-tune it back into post-training. Then we enhance it even more with test time, and the agents and agentic systems, put it out into the industry. And so this loop, the cycle, is going to go on and on and on. It kind of comes down to basically intelligence is going to scale by one thing, and it's compute.
But there's a tricky thing there that you have to anticipate and predict, which is some of these components, it requires different kind of hardware to really do it optimally. So you have to anticipate where the AI innovation is going to lead. For example, mixture of experts with sparsity.
Perfect.
With hardware, you can't just pivot on a week's notice. You have to anticipate what that's going to look like. That's so scary and difficult to do, right?
For example, these AI model architectures are being invented about once every 6 months.
Yeah.
Right? And system architectures and hardware architectures kind of every 3 years. And so you need to anticipate what likely is going to happen, 2-3 years from now. And there's a couple of ways that you could do that. First of all, we could do research internally ourselves. And that's one of the reasons why we have basic research, we have applied research, we create our own models. And so we have hands-on life experience right here. This is part of the co-design that I'm talking about. We're also the only AI company in the world that works with literally every AI company in the world. And to the extent that we can, we try to get a sense of what are the challenges that people are experiencing.
So you're listening to the whispers across the industry, the AI labs.
That's right. You got to listen and learn from everybody, and have a. And then the last part is to have an architecture that's flexible, that can adapt and move with the wind. And one of the benefits of CUDA is that it's, on the one hand, an incredible accelerator. On the other hand, it's really flexible. And so that incredible balance between specialization, otherwise we can't accelerate the CPU, versus generalization so that we can adapt with changing algorithms, that's really, really important. That's the reason why CUDA has been so resilient on the one hand, and yet we continue to enhance it. We're at CUDA 13.2, and so we're evolving the architecture so fast that we can stay with the modern algorithms. For example, when Mixture of Experts came out, that's the reason why we had NVLink 72 instead of NVLink 8. We could now take an entire 4 trillion, 10 trillion parameter model and put it in one computing domain as if it's running on one GPU. People probably didn't notice, I said it, but if you look at the architecture of the Grace Blackwell racks, it was completely focused on doing one thing, processing the LLM. All of a sudden, 1 year later, you're looking at a Vera Rubin rack. It has storage accelerators. It has this incredible new CPU called Vera. It has Vera Rubin and NVLink 72 to run the LLMs. It also has this new additional rack called Grok. And so this entire rack system is completely different than the previous one. And it's got all these new components in it. And the reason for that is because the last one was designed to run MOE large language models, inference, and this one is to run agents. And agents bang on tools. And
obviously, the design of the system had to have been done before Claude Code, Codex, OpenClaw. So you were anticipating the future, essentially.
Yeah.
And that comes from what? From the whispers, from the understanding what all the state of the art is.
No, it's easier than that. You just reason about it. First of all, you just reason. No matter what happens, at some point, in order for that large language model to be a digital worker, let's just use that metaphor. Let's say that we want the LLM to be a digital worker. What does it have to do? It has to access ground truth. That's our file system. It has to be able to do research. It doesn't know everything. We don't have, and I don't want to wait until this AI becomes, universally smart about everything, past, present, and future, before I make it useful. And so therefore, I might as well let it go do research. It's obviously, if it wants to help me, it's got to use my tools. A lot of people would say, AI is going to completely destroy software. We don't need software anymore. We don't even need tools anymore. That's ridiculous. Let's use a thought experiment. And you could just sit there, enjoy a glass of whiskey, and think about all these things, and it would become completely obvious. Like if I were to create the most amazing agent that we can imagine in the next 10 years, let's say it'd be a humanoid robot. If that humanoid robot were to be created, is it more likely that the humanoid robot comes into my house and uses the tools that I have to do the work that it needs to do? Or does this hand turns into a 10-pound hammer in one instance, turns into a scalpel in another instance, and in order to boil water, it beams, microwaves out of its fingers, or is it more likely just to use a microwave, And the first time it goes up to the microwave, it probably doesn't know how to use it, but that's okay. It's connected to the internet. It reads the manual of this microwave, reads it, instantly becomes an expert. And so uses it. And so I think I just described, in fact, almost all of the properties of OpenClaw. That it's going to use tools, that it's going to access files, it's going to be able to do research. It has I/O subsystem. And when you're done reasoning about it through it in that way, then you say, oh my gosh, the impact to the future computing is deeply profound. And the reason for that is I think we've just reinvented the computer.